Okay, let's spend more time on this idea of fraction equivalence and start to look at kind of some of the, you may recognize as algebraic representations. So first, the definition. One way that we can check to see if two fractions are equal is if the cross multiplication of those fractions, the cross product, is equal. And so you have this situation here. So keep that in mind because we're going to use that technique, right? And we also know that a fraction is equivalent to another fraction in this way here is if you take a fraction and multiply the numerator and denominator by the same number, that new fraction, this one here, right, is equivalent to the original fraction. And so it's important to note that this theorem can be used two ways. One, to replace a fraction a over b with a new fraction. 1/2 is 2/4, 1/2 is 3/6. Right? That's one way to do it. And then occasionally the term reducing is used to describe the process in two, right? Which is this idea of that when you have a bigger fraction, you reduce it. It kind of can be misleading since fractions are not reduced in size per se. We're just putting it in simplest form. So I prefer that statement there, saying that it's instead of reduced that we put it in simplest form, because reducing gives this idea that it's becoming smaller. The numbers are becoming smaller, right? So 4/8, some people will say reduces to 1/2. But it's not reducing. They have the same relative size. So really it's in simplest form now. Here are some examples of that. So for example, why are these fractions equal to each other? Why is 5/6 equal to 25 over 30? You can see the mathematics that has been done here. 5/6, 25 over 30 is 5 times 5, 6 over 5. And so then I can see that that's why it's 25 over 25. It's following this rule, right? You're multiplying the original fraction by the numerator and denominator by the same number. Those are equivalent. You can also show that those are equivalent by doing the cross multiplication. So that's another way. 5/6 is equal to 25 over 30 because when we cross multiply, get 150 equals 150. Which goes back to the definition of fraction equality right here, where you end up, it goes back to this here. The cross multiplication is equal, so the fractions are equal. Here in this next example, we look at simplest form, and so we rewrite the fraction, and then you see we end up with identifying that same number, numerator times the denominator, so you end up with 2/3. Same thing with 36 here. You're identifying what's the common number that you're multiplying by. What's that n? Remember what we said, a over b is equal to a times n over b times n. And that again had come up over here with this theorem over here. And so now you can continue on and see how that gets done. Here, this is a little more complicated where it gets simplified. On this one here, there's no simplest form because there's nothing that goes into it, so it's in simplest form. Here we have common factors, and we can actually use rules of exponent to do that problem there.